Good morning, everyone. Today we are going to discuss about the layout of the steam power plant and various circuits on the steam power plant. We are going to see the different circuits on the steam power plant. So we have a coal and ash circuit, air and gas circuit, feed water and steam flow circuit, and cooling water circuit. So we have a different circuit on the steam power plant. We'll see the different circuits and steam power plant. So first one is the coal and ash circuit. Second one is the air and gas circuit, feed water and steam flow circuit, and cooling water circuit. So first we'll see the coal and ash circuit. So before going to this steam power plant, layout of the steam power plant, we'll see the elements of the steam power plant. So we have a boiler, turbine, and generator. So to produce electricity or to produce the steam for the industries. So in the layout of hydroelectric power plant, we'll see the objective, the main function of the steam power plant is to produce the electricity. So here we have a boiler or a steam generator. Boiler is also known as the steam generator. So high steam will be generated from the boiler. So the boiler will be classified as a fire tube boiler and a water tube boiler. So nowadays, present days, we are using modern water tube boilers. The modern boilers are called as a water tube boilers. Water tube boiler. The water is circulating through the tubes and surrounded by the hot flue gases. So that is about water tube boilers. The water is circulating through the tubes and surrounded by the hot flue gases. Surrounded by hot flue gases. So from that boiler, steam will be generated. That steam, saturated steam, supersaturated steam will be striking on the turbine vanes, and the turbine starts rotating. That means it will be generating the mechanical energy. So steam will be expanding on the turbine. And turbine blades. Turbine starts rotating for generating the mechanical energy. So this input as the mechanical energy is to the generator. So from this generator, it will be converted as the electrical energy. So it will be producing to produce the electricity by using a steam power plant. So these are the various components of the steam power plant: boiler, turbine, generator, to get electricity, to produce the electricity. So these are the main elements, the main components. So furnace, boiler, turbine, condenser, pump. So here we have a boiler, then we have a turbine, then we have a condenser, then we have a pump. So this is about a cyclic process. These are the important components of the steam, main elements of the steam power plant. So now we'll see the circuits of the steam power plant. So this is about the layout of the steam power plant. So this is about layout of the steam power plant. You may observe clearly. So first, coal and ash first circuit will be coal and ash circuit. So this is about boiler. So this circuit will be. So here we have. So this is about the coal circuit, the input of the boiler. So in this boiler, the coal will be burning. That source of the heat is the burning of the coal taking place in the boiler. So boiler may be classified as a fire tube boiler or water tube boiler, whatever it may be. So the coal will be burned here. So the preparation of the coal storage, coal handling. So various stages in the coal handling system. So we need to prepare the coal and we need to size the coal. Transportation, chain conveyors, preparation. It will be transporting by using belt conveyor, chain conveyors, like that. We have a different various steps involved in the coal handling. From this coal storage. So we need to handle the coal handling, and this will be, and we need to size the lump sum coal will be broken into this small powder type of coal. So that means the pulverizing. We need to uh, pulverizing the coal. Pulverizing means the bada size coal, lump sum coal will be broken into our required shape, required size of the particle. Small amount of particles will be broken into pieces, and it will be transformed into as a form of powder. Pulverizing means it will be the coal will be in the form of powder form. It will be transforming from the powder form. So that coal will be comes the input of the boiler. So the coal will be fed into the boiler. The coal will be fed into the grate of the boiler. The coal will be fed into the grate of the boiler. So that here their combustion has taken place. Their combustion has taken place. So that is the input of the boiler. So the coal will be handling like this. Various steps involved in the coal handling. So that the coal will be in the form of powder form will be fine grade of the coal will be fed into this boiler grate, and burning of the coal has taken place in this boiler grate. After the coal, we need to remove the ash. So in the grate, in the boilers grate, we have ash pits will be collecting the ash. So we need to remove the ash also. Certain precautions will be taken due to the uh, ash will be removed very deep. Due to the hot ash, so we need to care properly. Ash handling equipment also will be there. So we need to cool the ash, and ash removal also will be very important in the steam power plant. So this is about coal. First circuit will be coal and ash handling. So from the boiler, we have ash pits, and we need to uh, ash handling equipment and the ash storage. From that, we need to store the ash from the. We need to store the ash in the ash storage. So coal handling and ash handling is a very important. This input and output of the boiler is a very important. That is about first circuit. Second circuit, air and gas circuit. So the coal and ash circuit, the coal arrives the storage yard, and after necessary handling passes onto the furnace through the fuel feeding device. Ash resulting from the combustion of the coal collects at the back of the boiler and is removed to the ash storage yard through the ash handling agent. We already seen that. Second one is ash and gas circuit. Ash and gas circuit. So in the air and gas circuit, air is taken from the atmosphere through the action of the forced induced draft and passes to the furnace through the air preheater, where it has been heated the flue gases, chimney and preheated. The flue gases after passing through the boiler tubes, that will be superheater tubes and furnace, and passes through the dust catching devices of respirator, then the economizer, and finally through the air preheater before the being exhausted atmosphere. Now we'll see the air and gas circuit in the layout of the steam power plant. So you may observe here air and flue gas circuit. So now we'll see the air and flue gas circuit. So you may observe here. So this air, this is about air from the atmosphere to this boiler, air preheater, through the air preheater. Here from the atmosphere, we need to heat the air by using air preheater. So that heated air will be that heated air heat from the air preheater will be entering to this boiler like this. You may observe in the air preheater. So that a heated air will comes to the boiler. So we need to heat the air. That heated air will be supplied to the boiler. So combustion has taken place. Without combustion, there is no without oxygen there is no combustible. Without oxygen, there is no possible of combustion. So we need to supply the air. We need to supply the sufficient air for the combustion purpose. So that we need to heat the heat air to the combustion chamber of the boiler. Then, so burning of the coal taken place. So burning of the coal taken place. After the burning, so hot gases will be flue gases. The flue gases will be generated. So from this boiler, these flue gases will passing through the. So you may observe this circuit diagram. The flue gases will be passing through the superheater. The superheater. These flue gases from the superheater, then it will be ghosting the economizer and air preheater and chimney, and then it will be goes to the atmosphere. Steam. These flue gases will goes to the superheater. So whatever flue gases will be there, that gases it has a energy, heat energy. So that heat energy will be given to this superheater. Then it will be given to the economizer. After that, it will be given to the air preheater. After that, these hot flue gases, so precipitator, electrostatic precipitator, or any from the dust collector, we need to collect the dust from these hot flue gases, and we need to release these hot flue gases into the atmosphere. So that energy, total heat energy will be given to these. So after water is converted into the steam, that flue gas has some heat energy that will be given to this superheater. So this superheater, economizer, and air preheater, like this, that flue gases will goes to the atmosphere. So these are the accessories of the boiler. Superheater, economizer, air preheater is the accessories of the boiler. For increasing the efficiency of the boiler, we need to use the accessories like superheater, economizer, air preheater. These are the boiler accessories for improving the efficiency. Whereas we need to have a boiler mounting for in order to operate the boiler in the safe manner, we need to use various boiler mountings like pressure gauge, safety valve, steam safety valve, pressure gauge, uh, then water level indicator, feasible plug, like that. We have various mountings also will be using for operating the safe manner of the boiler, right? So this is the second circuit, air and flue gas circuit. The air circuit, air from the air, from the atmosphere, that air will be entered into the air preheater, then it gets heated. That heated air will be supplied to this boiler. Then, so the combustion has taken place, coal has burned, the heat, hot flue gases will be produced. After the water will be converted by absorbing this heat, it will be converted as the steam. So the steam will be flowing like this, superheater and turbine. Later we'll see. So whatever the hot flue gases, whatever the heat will be there, that heat also will be given to the superheater. Flue gases will be passing through like this. Okay. These flue gases will be like this. You observe in the you may observe boiler, superheater, economizer, and air preheater, and then through the chimney it will be goes to the atmosphere. So this is about hot flue gases, air and flue gas circuit. Now we'll move to third circuit, that is about steam flow. How the steam will be flowing. Feed water and steam flow, feed water and steam flow circuit. Steam water and feed water, steam flow and feed water circuit. So, water gets in. Water gets heated in the boiler, then the water will be converted as a steam. That steam will goes to the any moisture content will be there, so that will be entering to the superheater. So if any moisture content in the steam, any moisture content, so that will be removed. That wet steam will be converted in the superheater. That wet steam will be converted into the superheater. So that dry steam or a supersaturated steam, or superheated steam that superheated steam will be striking on the turbines. The supersaturated steam will be striking on the turbines. The steam expanding on the turbine blades and the turbine starts rotating. Turbine starts rotating. That means it will be generating the mechanical energy. That will be generating the mechanical energy. So here steam will be expanding here. So it gets steam gets expanding. So we have a reactions turbines and impulsive turbines like this. So the steam will be expanding on the turbine vanes and the turbine starts rotating. It will be generating the mechanical energy. So that mechanical energy as the input as the generator. So the output will be it will be converting the mechanical energy into the electrical energy. So that electrical supply will be given to this grid system. The output of the generator is electrical energy. That power will be that electrical energy is given to the, it will be connected to the grid. So the turbine shaft is directly coupled with the generator. You may observe here, the turbine shaft is directly coupled with the generator. In this way, the steam will be flowing like this from the boiler. Boiler is also called as a steam generator. Steam will be generating here. The steam will be flowing from superheater. Superheater, it will be converting the wet steam into as a dry steam. If any moisture content present in the steam, that will be removed with the help of a superheater. After the superheater, it will be goes to the steam safety valve, steam stop valve. So the main valve, it will be regulating the flow of the steam, and then it will be goes to this turbine. It will be starting on the turbine vanes. It will be expanding on the turbines. It will be creating the mechanical energy. After that, exhaust. So this steam will be goes to this condenser. So in this condenser, phase change will be taken place. So it will be converted as the, so that the steam will be converted as the liquid state. Phase change take condenser phase change taken place. Phase change are taken place. So that heat will be removed with the help of this uh, cooling tower circuit. So this is about a cooling tower circuit. So it will be observed here. So the water last flow circuit will be, fourth circuit is the cooling tower circuit. Fourth circuit will be cooling tower circuit. So from this exhaust steam, that where steam will be condensed and it will be converted as a liquid. So heat. So here heated liquid will be there. So that heated will be. So here we have a cooling tower will be there. So we need to supply the water to this cooling tower. So this heat taken by the heat taken away by the water. The heat will be taken away by the water. So we need to use cooling towers. That heat will be taken away by the water. So that water, again the water will be, we need to use again that water is feeding to this boiler. You may observe in this diagram. So here we have a pumps and condenser extraction pumps and low pressure heater. Then we need to high pressure heater. Then the water will be feeding to this economizer. You may observe this diagram. Again the water from this cooling tower, the water, again the water will be goes to this economizer to the boiler. You may observe the diagram. So from this condenser, so here the water will be moving. The feed water will be given to the economizer, then economizer to the boiler. What is the purpose of the economizer? It will be heating the water. It will be heating the water. That preheated water, preheated. So air preheated, that preheated air will be supplied to the boiler. At the same time, by using the economizer, one of the important accessories of the boiler, that preheated the water. That heated water will be goes to this boiler. It will be the heated water will be feeding to the boiler. The feeding water, heated water will be supplied to this boiler. So that means it will be consuming the, it will be saving of the coal percentage. So by using these accessories, it will be saving the coal. So the hot flue gases will be passing through the superheater, economizer, and air preheater. That waste heat energy will be given to this superheater, economizer, and air preheater. So from this economizer, the water will be preheated. The preheated water will be supplied to this boiler. So this is about the four circuits of the steam power plant. So first one is coal and ash circuit. First one is coal and ash circuit. Coal will be supplied to the boiler, and then after combustion, ash will be generated, ash will be produced. That ash we need to remove from the boiler. So it is a very difficulty. Uh, we need to remove that at any cost. We need to remove that ash from this boiler. So ash handling equipment also will be there. So second one is the air and flue circuit. Air and flue gases. Air and flue gases circuit. So that air will be there, and hot flue gases will be goes to this like this. Third one is the steam flow, and feed water and steam flow. So steam from this boiler to this superheater, superheater to turbine. So this is about steam flow. Then we have a cooling feed water and cooling tower. Sir. Cooling tower, from this exhaust gases, we have a condenser, another important after the component, another important component of steam power plant, that is about condenser. So here we need to phase change. Condenser means phase changing taken place, so that it will be converted as steam, will be converted as a liquid. That hard will be given to this cooling tower. Again, the water will be feeding to. Again, the water will be feeding to the economizer. From the economizer, that water will be goes to this boiler. So I hope you are understanding the concept of the layout of the steam power plants and various circuits on the steam power plant. You may observe very clear. So these are the four important circuits: coal and air circuit, air and gas circuit, feed water and steam flow circuit, and cooling water circuit. So these are the four important circuits in the layout of the thermal power plant or layout of steam power plant. I hope you are understanding the concept of working of the and layout of the steam power plant.